All right, so I had actually started on 40, made a mistake, deleted it all, and then I went back and fixed it. And I'll explain what I've done here. I was getting a time that didn't make sense because I can't seem to comprehend things apparently today. But suppose Rand leaves home traveling at a constant rate of 20 kilometers per hour. Matt leaves 3 hours later, traveling at a constant rate of 15 kilometers for the first hour, a constant rate of 18 to 21 seconds, and so forth, with his speeds forming an arithmetic progression. To the nearest minute, how long has Matt been traveling when he catches Rand? So what I did is I created some equations. An equation for Rand is that his distance traveled is 20 times the time he's on the road. For Matt, I wrote out the arithmetic sequence and I came up with an equation for him. Now, it's not about when those two things are equal. That won't get you the right answer. It's about this, because that would tell you at what time they're traveling the same speed. That's something you got to be careful about, because I was tempted to do it too. But if you set 20t equal to, I guess his equation should probably be t plus 3, whatever. But if you set 20t equal to 3t plus 12, that tells you what time speeds are equal. That's all it tells you, what time speeds are equal. Now, what it's actually asking you to do is figure out when the distance is the same. All right? What time is the distance the same? Which is saying when are the sums of the same? So here we have on Rand the sum of 20s, and on Matt we have the sum of 3t plus 12. I wish I could get that all in one line there. Anyways, let me just delete this and start over, and I'll try and explain it. Now, you're supposed to know your summation formulas. I'll try and show this an easier way too if I can. We'll see if I can. There's two really good choices, and then there's some really bad ones. But since he's the sum of 20s, he is going to be, look up the right board here. Hope it doesn't knock out my audio. He is going to be n over 2, and we don't know what n is, times 20 plus 20, first plus last. No, he has a head start. He's actually n plus 3. Here's has a head start. He's 3 terms ahead. Rand is going to be his first term, which is 15, and we don't know n, by the way. But we do know his general formula. The last term is simply 3n plus 12, whatever n is. Whatever that is, that's the setup. It's the best setup I could figure out. Please tell me my audio is still recording. Yes, it is. Sometimes when I plug stuff in, it goes dead. So I put those equations in y1 and y2. I'll do a zoom 6 just so you can see through progression of the window settings. There's Rand. Here's Matt. They obviously intersect somewhere down here, but if you understand the shapes of parabolas, they will eventually catch up. I'm going to set my y max to be something like 500 kilometers, because that's distance and it's in kilometers. The line doesn't look quite as steep anymore, does it? And you can see that the red curvature catches up to it. So second trace 5, enter, enter, enter. Oh, it honed in on the negative solution. Let's do that again. Second trace 5. Maybe this time I'll get close. That's good enough. Enter, enter, enter. There we are. 8.85207. I don't know if you've noticed or not as I've done this video, but a lot of this is y1, y2. But you do have to have the God-given intelligence to be able to set things up, and that is kind of difficult. So I know I got 8 hours. Let's take that 0.852 and multiply it by 60 for my minutes. It ought to be close enough. 51. I'm a little curious if we can get through this by kind of cheating our way through it, by just writing out the distances that are traveled. Now remember, Matt has a head start, so he covers 20 kilometers, then he covers 40, 60, 80, 100, 120, 140, 160, 180, 200, 220, 240, 260. Now Rand has 3 blanks here. And then he starts moving. 15. The next one is going to be 15 and 18, 33. The next one's going to be, and that's kind of where it gets, because you got to think about what's actually going on here. There's an 18 in between. Now he's sped up to 21, he's sped up to 24, he's sped up to 27, he's sped up to 30, he's sped up to 33, he's sped up to 36, he's sped up to 39, he's sped up to 42, 45, 48, and so forth, because he's increasing at 3 miles per hour. So at the next interval, we're at 54, then we're at 78, then we're at 105, then we're at 135. Now we're sitting around what, 168? And now we're going to catch him. Sometime here we're going to catch, because we're going to add 36 and get to 204. So let's count our hours. 1, 2, 3, 4, 5, 6, 7. Oh, how long has Matt been traveling? Let's get rid of those 3 blanks. 2, 3, 4, 5, 6, 7, 8. He caught him really close there, didn't he? Yeah. Sometime by the end of the 8th hour, he caught him. You'd be tempted, though, to round that down, but sometime near the end of the 8th hour, he caught him. He was still on the 8th hour. This is at the end of the 8th hour. By the way, I mentioned that. That's at the end of the 8th hour, not at the beginning. This 15 kilometers would be at the end of the first. But at some point in time, at the end of the 8th hour, he caught him, and that lines up with choice B. So I guess you could do it non-algebraically. I guess. I don't like it, but it's doable. And that is what has consumed my time for the last 2 or 3 days.